Robot programming. In this video, we will learn the basic robot commands. Consider the following grid. The triangle at the center of this grid is a robot. All robots have location and direction. We describe the location by first stating the row number, then the column number. For example, the location of our robot currently is R3C3, which is short for row 3, column 3. The direction of the robot is found by determining which direction the top of the triangle is pointed towards. Currently, our robot is facing up. Now it's facing right. Now it's facing down. Now it's facing left. Now it's facing up again. All robots have two rotate commands. First, there's the rotate right command, which rotates the robot 90 degrees clockwise. And then there's the rotate left command, which rotates the robot 90 degrees counterclockwise. All robots have one move command, and that is the move forward command, which moves the robot one square forward in the direction it is currently facing. For example, our robot is currently facing up. Hence, if we were to invoke move forward on it, it would move one square forward in the up direction. Now suppose the robot were facing right. If we invoke move forward, then it would move forward one square in the right direction. Now suppose the robot was facing down. If we invoke move forward, then the robot will move one square forward in the down direction. Now suppose the robot was facing left. If we invoke move forward, then the robot will move one square forward in the left direction. With that all said, currently our robot is in R3C3 facing left. Consider the following program. Here we have a program with 5 statements. Suppose we were to execute each of these statements in order, starting with line 1. Line 1 says to move forward, so the robot moves forward in the direction it's facing. Line 2 says to move forward again, so we do that, we move forward. Line 3 says rotate right, so we do that, we rotate right. Line 4 says move forward, so we move forward. And line 5 says move forward, so we move forward once again. Executing these 5 commands resulted in the robot being located in row 1, column 1, facing up. Now suppose we were to add one more move forward command to the program. When we execute that, this would result in a robot error because there is no open square in the forward direction. Anytime an instruction results in the robot moving off of the grid, we call that a robot error, and anytime a robot error occurs, that ends the program. This brings us to the 4th and final command that all robots have. The canMove command, which receives one parameter, a direction, which will either be forward, backward, left, or right, then returns true if there is an open square, one square in the direction relative to where the robot is facing. Otherwise, it returns false. Now, that is a mouthful, so let's go ahead and illustrate what I meant by all of that. Currently, the robot is located in row 1, column 1, facing up. In that case, if we were to invoke canMove forward on this robot, we get false because moving the robot forward in the up direction takes us off the grid. There is no open square in the forward direction. That being said, canMove backwards would return true because there is an open square in the backwards direction. Likewise, canMove right would return true because if we were to rotate the triangle right and move forward, we would land in an open square. However, canMove left returns false because if we were to rotate in the left direction and move forward, we would not land in an open square. We'd move off the grid. Now, suppose instead of facing up, the robot started off facing left. In that case, canMove forward will return false because there is no open square in the forward direction. However, canMove backward would return true because there is an open square in the backwards direction. Can move right would return false because if we rotate the robot right and move forward, we would not land in an open square. Can move left, however, returns true because if we rotate left and move forward, we would land in an open square. Now suppose the robot started off facing down. In this case, can move forward returns true because there is an open square in the forward direction. However, can move backwards returns false because there is no open square in the backwards direction. Can move right would also return false. And this might be counterintuitive to you because you might be assuming that your right is the robot's right, but that's not the case. Your right is not automatically the robot's right. The right side for a robot is the direction the robot would be facing if they were rotated right or clockwise. And if we were to rotate this robot right, that is the direction it would be facing. So in a situation where the robot is facing down, our right corresponds to the robot's left, and our left corresponds to the robot right. With that said, if we were to move one square forward, we'd fall off the grid. There is no open square in that direction, hence why can move right returned false. Can move left, however, returns true because if we rotate left and move forward, we do land in an open square. Now, suppose the robot started off facing right. In this case, can move forward returns true because there is an open square in the forward direction. Can move backwards returns false because there is no open square in the backwards direction. Can move right returns true because if we rotate right and move forward, we do land in an open square. Can move left, however, returns false because if we rotate left and move forward, we do not land in an open square. Now, suppose, for example, we move the robot to row 4, column 3. In this case, the can move command will return true for all 4 directions because there is an open square in all 4 directions of the robot. This would be the case if the robot were facing right, down, left, or up. When there is an open square in all 4 directions, we know the can move method will return true for all 4 directions. With that said, one thing to prepare yourself for is that grids do not necessarily have to be 5 by 5. A 5 by 5 grid is what we use for this video, but grids do not have to be 5 by 5. They can be 3 by 5, 2 by 4, 3 by 3, 10 by 6. There is no specific length or width a grid must have. Something else to prepare yourself for is that not all blocks will always be accessible. For this video, we kept all 25 blocks of our 5 by 5 grid accessible at all times, but on a test or AP exam, that may not always be the case. For example, on a test or AP exam, you may encounter a grid where some of the blocks are painted black. When a block is painted black, that indicates that the robot cannot move there. Hence, if I were to invoke the can move forward command on the robot as is, we'd get false because moving the robot forward would land us in a block that's not accessible. Likewise, if we were to invoke can move right on the robot, we would get false because rotating the robot right and moving it forward would land us in a block that's not accessible. However, can move backwards would still return true because there is an open block in the backwards direction, and can move left would also return true because there is an open block in the left direction.